Hello friends, previous lecture we studied the Wheatstone's balancing condition for the resistances. The Wheatstone's balancing condition for resistance is R1 by R2 equals to R3 divided by R4. This is the Wheatstone's balancing condition for the resistances, and the resistance are arranged in this way. This is the first resistance R1, second resistance R2, third is the R3, and the last resistance R4 is here. And between these two points, point B and point D, are my equipotential points, and between these 2 points a galvanometer is connected here, and the balancing condition is R1 by R2 equals to R3 by R4. Today we see the applications of the Wheatstone's balancing condition, and the first application is Wheatstone's meter bridge. With the help of this meter bridge, we measure, or using this Wheatstone's meter bridge, we measure the, or we determine the unknown resistance. Value of unknown resistance. Also with this meter bridge, we can measure the resistance of galvanometer, that is my Kelvin's meter. Now we see how meter bridge is drawn, what is the shape of the meter bridge, why it is called as a meter bridge, why it is a bridge, all the things we study in the today's lecture. First of all, see Wheatstone's meter bridge. Now just I am showing a 1 meter bridge to you. Just we write down the balancing condition for the Wheatstone's network. Now this is simple, a Wheatstone's meter bridge. Now on there is a one wooden platform is there. On that wooden platform, a thin uniform conducting metal wire. Remember, thin means whose cross sectional area is very small. Thin. Uniform means its thickness is remains same, its cross section area is remains same. Thin uniform conducting means from which current is carried. Such a thin uniform conducting wire. Just I am drawing. This is the point A and this is the point C. This is a thin uniform conducting wire is connected here, or is fixed on a 1 meter scale. Below that there is a 1 meter scale is there. On the meter scale there are number of markings are there. Like this is of 50. This is a 1, 2 in this way up to 50, and this is up to the 100. So just I mark here, this is a 1 meter point and this is the 100 meter point. Okay, and on that there are number of markings are there. This wire is thin. Okay. Secondly, the condition for wire is a uniform. Uniform with respect to what? Uniform with respect to cross section area, that is capital A. Okay. The length of wire is how much? The length of wire is about 100 centimeter. And remember that 100 centimeter means 1 meter. So the name is a meter bridge. Now why it is called as a meter bridge? On the wooden platform, a 1 thin uniform conducting wire whose length is about 1 meter is stretched, okay, between the points A and C. These are my 2 points, and on that there is a thin uniform conducting wire is stretched. 3 metal strips. This is a 1 metal strip in English letter L, second metal strip, and the third metal strip. 3 metal strips are fixed. 3 metal strips are fixed. Here the 3 metal strips are fixed. This is the 1 metal strip. This is second metal strip, and this is the third metal strip. The 3 metal strips are fixed on a wooden platform in such a way that it forms 2 gaps. There is no any metal. There is a totally gap. 3 metal strips are fixed in such a way that it forms the 2 gaps. There is only wood. Wood is a bad conductor of electricity, means there is a 1 gap, second gap. 3 metal strips are fixed in such a way that it forms the 2 gaps. There are the 2 gaps are formed. Okay. Now this is my point B. Okay. One end of galvanometer is connected to the point B, and other end of galvanometer is connected to one sliding key or jockey. This is my sliding key, means this key will be slide on this wire. So it is called as the sliding key. Is fixed. Suppose it will be reached up to the point D. Okay. This gap is a left gap, and this is a right side gap. In the left gap, a resistance whose value is not known, that is connected. Let it will be X, and this is my unknown resistance whose value is not known. Such a resistance is connected in the left gap, and in the right gap, resistance box from which we can remove a known resistance R is connected here. A cell key and variable resistance called rheostat are connected in series across the points A and C. These are my 2 points A and C. This is my cell. This is a positive terminal of cell, negative terminal of the cell. This is a key, symbol is a K, and this is a rheostat. Symbol is RH. From this, electric current is flow from positive terminal. This current reaches up to the point A. From this part, some amount of current is flowing, and remaining current flow through this unknown resistance. Now, remove a one suitable resistance from resistance box. Choose any one resistance from resistance box. Remove that key. Then the current it will be start to flow, and slide this jockey. We can slide this jockey from this point to up to end point. We can get zero deflection inside the galvanometer. Why we are getting the zero deflection, or what is the meaning of zero deflection? If galvanometer shows zero deflection, means what? No current flowing through galvanometer, because the function of galvanometer is what? To detect the charge. Okay? To detect the current. If no current is there, then obviously it shows the galvanometer. So slide the jockey till your galvanometer shows the zero deflection, and that point is called as the null point. It means we can slide the jockey till galvanometer shows the zero deflection. That point is called as the null point. Now apply here. Just observe. This is my upper part. This is my lower part. What is the balancing condition? Left resistance of upper part. What is the left resistance of upper part? Is X divided by, okay, divided by R2. R2 means what? Right resistance of the upper part. The right resistance of upper part is how much? Is capital R is the right resistance of upper part equals to left resistance of lower part. Okay, but there is no any resistance, then how you can write? Then it will be very simple. Resistance is given by rho L divided by A, as A is a constant because my wire is a thin and uniform. Uniform means what? Cross section area is constant, means A is constant. Rho means specific resistance or resistivity. It will be depends on material. So rho and A are constant. Only capital R is proportional to the L. So I am writing left side length is how much? It is corresponds to unknown resistance X. This is corresponds to known resistance R. So it becomes, instead of resistance, because R is proportional to L, so I am writing it becomes a Lx upon Lr. What is Lx plus Lr? It is of 100 centimeter. So my new formula becomes x by r equals to Lx upon 100 minus Lx. These are the two important formulae. With the help of these two formulae, we can easily find out the value of unknown resistance. This is the balancing condition. R1 by R2 equals to R3 by R4. And this is most important formula. With the help of this formula, we can find out the value of unknown resistance, left line, left side length or right side length or known resistance. Any one value, if the three values or two values are given, we can find out the any one unknown value. And how you remember this formula? Left resistance upon right resistance equals to left length upon right length. Remember, in the application balancing condition, how converts it? Left resistance upon right resistance equals to left side length upon right side length. Okay, I think it is clear for everyone. Just go through the book, read the same part, and now we see one example which is very easy example on this part. Okay, first see what is that example and then we start to solve. The example is very simple. Just I am taking one simple example which is based on this balancing condition. Just I am writing the example. All the students see the example, note down that example. Okay. In meter bridge, resistance of 30 ohm and 40 ohm are connected in left and right gap respectively. Balancing length is 50 centimeter from left end. Okay, if both resistances are increased by 10 ohm, what is new balancing length from left end? This is my question. Now the answer is also simple. Now in a meter bridge, the resistance of 30 and 40 ohm are connected in left and right gap respectively. First, remember the balancing condition. Left side resistance upon, I am writing in this way, resistance divided by resistance. This is the left resistance upon right resistance equals to left resistance upon right resistance equals to length. Left side length upon right side length, or simply x by r equals to Lx upon 100 minus Lx. The first resistance is of 30 ohm, right side resistance is of 40 ohm, left side length is how much? 50 centimeter. Then remaining is how much? 100 minus 50. So it becomes a 50. Are you getting this part? Okay. So answer becomes a 3 by 4 equals to 1:1 as it is. Are you getting this part very clearly? Now come. If both the resistances are increased by 10 ohm, both resistances are increased by 10 ohm, means left becomes 30 plus 10, right becomes 40 plus 10 equals to Lx upon 100 minus Lx. So it becomes a 40 by 50 equals to Lx upon 100 minus Lx. So it becomes a 4 by 5 equals to Lx upon 100 minus Lx. Make a cross multiplication. So 400 into 4Lx equals to 5Lx. So 400 equals to 9Lx. So Lx equals to 9 4s are 36, 9 4s are 36, 44.4 centimeter from left end. This is my answer. Are you getting this part? Yes? Okay. In the same way, I will provide you some PDF, some questions. You can solve this, and also I am providing the note. Just to write down that note. Okay. Read the same part from textbook so you get very clear idea.